Welcome back. We're at episode 30 now. We're going to continue on with our parallel operations with applicatives. This is number 3, the third time kind of looking at it here. I'm still Reed Evans, and I thank you for watching. We're still dealing with our futures because we're talking about parallel operations. We still have our home page, but in this case, our home page we're just going to say takes an array of really anything, and we're just going to stringify whatever it is. That may not be too realistic, but I think when you get down and I show you where the inspiration for using this traversable is, that you'll see when you might actually use it. You can probably come up with better use cases than this. So we still have this concept of we have our current user f, which just returns a feature of our current user. And then we have a user f, which, given an integer, will return a feature of either an error or a user, same as what we had in the last episode. And then get user f, which chains those things together. Once again, it's the exact same that we had in the previous episode. This posts f has stayed the same for like 4 episodes now, so nothing new or exciting happening there. Well, I guess 3 episodes now, because this was 28 when I did that. But what we want to look at now is, what if we had an array of futures, or some potentially unknown number of futures? Because the previous implementations that we had were limited in that if we wanted to add one more thing here, we had to add another argument. We had to keep adding all these different arguments. But what if we wanted to be able to just say, hey, you know what? We just want one argument, it's an array, and it's going to give us a bunch of different stuff. So it turns out we can do that. And it's pretty neat. So we have a futures list here. So we have this futures, and it's an array of futures that are either an error or some type. In this case, getUserF is a different type than posts f. This wouldn't work in a lot of different languages, but because of JavaScript, this actually does all work. And we're going to use this function called sequence, and it comes from Ramda. This is not something that I wrote, but as it turns out, it's a well-known mathematical thing. It's a provable thing that you can do, and it's got kind of a scary function signature. So we're going to look at the function, at the scary one first, but then we're going to break it down right after it. So basically, because this is a really good practice for reading these function signatures. So what we're saying is we have some type f and some type t. And we're constraining f and t to say that f has to be an applicative, t has to be a traversable. And we're saying that given a function from an a to an applicative of a, in other words, being able to lift that one value up into an applicative, given a function from a to f of a, and then we have a t of f of a, so a traversable of f of a, we can return an applicative of a traversable of a. Well, what's a traversable? We haven't seen that before. Well, as it turns out, a traversable is an array, and you can think about that. It makes sense because you can traverse through an array. So if we were to look at sequence, take the type classy stuff out of it and say it was just defined for futures and arrays, then future is going to be our applicative, and array is going to be our traversable. So we can remove all of that kind of junk, and we can say that more simply, given a function from an a to a future of a, which as it turns out future.of is exactly what that does, and then we have an array of futures of a, we can then end up returning, if we call sequence, we can return a future of an array of a's. And so what you probably have seen this before is if you've done any C# with the task parallel library, you've got task when all, or if you have dealt with JavaScript at all with promises, there's the promises when all or whatever they created as the name for that. But basically, it takes a list of promises and returns you a promise of a list of values. And it's exactly what this does, but as it turns out, this is mathematically provable. So what does this all look like? Well, we're going to create a constant called inverted future, or invert future, and it's going to take an array of futures of error or any, and it's going to return a future of an error or an array of any's. which is basically just because we're calling this sequence function. And we've already kind of walked through the way that this signature worked. So then what we can do is we can call invert futures, and we can pass our futures array to it, and then we can fork over that guy, and then on our success branch we can call our homepage function and pass that array in, which is this success value here. So once again, our homepage just takes an array of any's, throws it in a div, and just stringifies the thing. So if we're to run this, we get a syntax error on line 30 because I haven't commented this. And if we were to run it again, then we would get what we would expect. So if we were to look at our children for this here, we still get the same stuff that we've been seeing for the others, but now we don't really care. We basically can make sure that this home page always has an arity of 1, or said another way, it only ever accepts 1 argument, versus no matter how many now futures that we pass. We could do another future added into here and it would still work. We would get a third option. Versus the other way that we were doing it, where we had to have named parameters, and basically our home page, if we wanted to add an additional future to our list or whatever, would have to take an additional argument. So there you have it. This is still using applicatives. They're really, really powerful. Still using the applicatives, but we've introduced this new thing called a traversable. The main one that you're going to see probably is our arrays. Turns out arrays are traversable. There are other types that are, but in this case, traversable could be really easily used because array implements that type class. So basically, the concept here is that if we call this sequence function, it kind of inverts the thing. So from an array of futures, we can return a future of arrays, or a singular array, I guess I should say. So there you have it. It's getting late. I'm going to sign off here, but that's episode 30, taking a look at some of the other cool things we can do to still very, very cleanly deal with this concept of parallel operations, making sense using them in our app, and really having our code not know anything about the fact that we've got parallel operations or anything else. Anyway, I hope you enjoyed it. Episode 30, I've been Reed Evans. Thank you.